now I have modified my Meet ETX 125 to accept. So I think I will use the max vision with this. It goes better, gives a better result. Looks heavier. Collimating a short tube Newtonian is difficult. I must say it's really difficult compared to long focal length Newtonians or things like that. Short tubes have a tendency not to be able, because a little amount of tilt leads to a big shift in the direction of the light rays. So I've not seen anything in the YouTube about this, but I found in a forum about something about it. I give the link below, and in that forum it was actually describing what you have to see, and practically I rediscovered what I discovered when I was a kid. So we go first through the laser collimator, and I will show that laser collimation is not adequate for the short tube Newtonians. Then I will go for the method that I discovered when I was a kid, and I refound it again, rediscovered it again in a forum in the internet. That is for short tube Newtonian. This is a f5 telescope. It's a 15 centimeter 6-inch Newtonian telescope. It's quite lightweight. I put it on the originally I put it on the Celestron Nexstar 5SE. Now I put it on the Virtuoso Skywatcher Heritage Virtuoso mount, and it really holds it well. Of course, you have limitation. You cannot go to the zenith because of the length of the tube. I'm going to collimate this 6-inch 15 centimeter telescope. Is a short tube Newtonian reflector, and for this I need a screwdriver, I need a laser collimator, which I will show you, and you don't need a Salyut 7, but if you watch it, that also shows that you're interested. It's one of the best sci-fi movie you can watch, actually based in reality. And so what I need is to adjust the secondary mirror, which is here. And with the use of that laser collimator, then I do the back cell also. The first primary mirror also will be collimated. Let's do it. Increase the intensity of the laser beam to 5. And as you can see, is now doing the intense beam inside. Now to use this screwdriver to adjust this mirror. There are 3 screws and this central one. Let me see which one of them will actually move the secondary mirror's position. You can see now I have brought the laser almost to the center of the mirror. I hope you can see it. And I just adjusted these 3 screws one by one. You see which direction it moves. To turn the telescope around and look through here, just facing toward me the other direction, this way, and adjust the back cell. I've adjusted the position. It's in easy position to reach for me. I can reach the back cell, the primary mirror, to collimate the screws. and I can see the laser beam here roughly. What I have to do is to bring this laser beam to the center of that hole. Let's do it. So with this screwdriver, I will adjust these screws. 1, 2, and 3. One by one, I will adjust them to see the shift in the position of that laser beam. I love it when it is not the way that it should be. Okay, this is the secondary mirror, and this is the view through the secondary mirror. I've now adjusted it. It was not originally adjusted in a way that you could see exactly the outline of the tube. But now I've adjusted it so you don't see any part of the tube missing. If I adjust this camera in a way, you can see exactly everything is at the center. So the reason is that this is a short tube. With the short tube, the secondary mirror doesn't need to be exactly 45 degrees. You can adjust it a little bit to have the full view of the tube. All the sides of the tube should be visible. And in a short Newtonian, that can be achieved by putting the secondary mirror slightly offset. Instead of 45 degrees, you can just change the amount of the angle of the secondary mirror up and down. You have to see it how it is to bring everything concentric. So in this view, you can see that I'm talking about the ring around the view, field of view, which shows those tiny notches. They are one of them is a focuser to the right and to the left, and the right one is the clamp which holding the mirror. Those should be equally visible, and in this case you can see more or less they are visible. So that means the tube is completely, I can see the tube. What that means is that I'm not seeing just part of the mirror like an almond shape or eye shaped something, but I can see the circle. If you are trying to adjust a short Newtonian, you will notice what I mean. So I'm seeing the whole width. By almond shape I mean something like this, for example, something like this. You will see it something like this. That means if your telescope is 15 centimeter, practically here you are not seeing the whole span of your mirror. Your light gathering is reduced, is less than 15 centimeter. So you have to bring the mirror in a way, secondary mirror, in a way that you can see the whole width, the whole diameter, the whole circle of your mirror. So this is the way to do it. I'm trying to say I started to use laser, but now I found that without laser, actually I can do it. Without laser collimator, just using my own eye and using this screen, the window as this brightest screen as a landscape, I can see the whole width of my first primary mirror. And I just adjusted this, and adjusted this in a slight way. Now the telescope is perfectly collimated. So sometimes you end up with an unexpected result. In this case, I collimated my mirror by just using a visual method. I started with the laser collimator. I ended up using my own expertise. I remember when I was a kid, I had a Gilbert telescope. And after a while, I noticed that I can actually adjust the mirror. I didn't know anything about collimation or anything. I just saw that through the eyepiece, when I removed the eyepiece, through the eyepiece focuser, I could see the mirror is like this. Kind of, not the whole width of the mirror is visible, primary mirror. So I just tried to move it, and I noticed that in the back cell, where the mirror is held, there are knobs, there are screws that I could actually turn them. And by turning them, I noticed that the mirror is moving toward up, the secondary mirror image you can see here, or down, or left, or right. In this case, you see right or left. And I adjusted it like that. So by just intuition, I found that. I discovered it on my own. God, we discover many things on our own when we are kids, aren't we? Don't we? Yeah. Anyway, that's this telescope. Short tube is f5. And I got it for £50 from somewhere in YouTube, and it works now in the eBay.